The last part of this section, we're going to take everything that we know about being able to work with our binary and decimal, and we're going to look at the computer representation of being able to do 8-bit addition. Now, 8-bit addition is basically how the computer is going to work with a half adder and a full adder. And it's just a way for the computers to be able to work with these numbers. And again, at the very crux of what a computer is, it's ones and zeros, it's impulses. And so we have to understand how computers work at the microprocessor level with this addition. So just making sure before we go into actually doing any problems that we understand how the computer registration works. So in a computer register, we're going to go through, we're going to start with a sign bit, and then we have 2 to the 0. So it's going to be 8 bits. So it's 2 0 to the first, 2 square, 2 cube, 2 4, 2 5, and 2 to the 6th. And then there's the sign bit. All right. So these are our 8 bits. All right. Now the sign bit by default, whenever a computer reads in a number, it's always going to start out as 0, and then it's going to convert over to negative. And if a number, essentially, let's say the computer reads in -23. So what it'll do first is it'll convert 23 into binary, and then it reads this negative, and it does something called the twos complement. And the twos complement's really easy. All you do is you just flip all the bits. So you just change 0 to ones, ones to 0, and then you add a binary 1. And let's talk about really quickly what it means to add a binary 1. So let's say we had 1 plus 1 in binary. Well, 1 plus 1 we know is 2, but there is no 2 in binary. Instead, 1 plus 1 is actually 10 in binary. And what about 1 plus 1 plus 1? Well, 1 plus 1 plus 1 is 3, but there is no 3 in binary. There's an 11, which is 1 plus 2. So we have to keep in mind that there are no 2's in binary. There are no 3's. Every time we add, there's going to be a carry. We just have to be careful with this carrying register. Right? So with all that being said, let's talk about the idea of being able to perform 8-bit addition. Right? So here's the steps that we're going to do. We're going to change all the numbers into their binary form. That's easy. We just did that in the previous section. Any negative numbers, we find the twos complement. And we're just going to use a 1 for the negative position. Right? Then we're going to add the binary numbers, and anything that's past the sign bit at 2 to the 8th position, we're just going to truncate it. And then if for some reason we get a negative number, in other words, we get the sign bit of 1 at the end, then what we're going to have to do is we're going to have to flip it back, and we're going to have to use the twos complement 1 more. Okay. All right. So let's take a look at a couple examples as to how we're going to go through and perform 8-bit addition. Let's start with an easy one. Let's start out with something like 49 plus 55. All right, so here's what we're going to do. We're going to start out with our sign bit, and we have 2 to the 6th. And remember, 2 to the 6th is 64, and then 2 to the 5th, which is 32, and then 2 to the 4th, which is 16, 2 cube, which is going to be 8, 2 squared, which is 4, 2 to the first, which is 2, and 2 to the 0, which is 1. And what we're going to do is we're going to convert both of the decimal numbers into binary. All right, so let's start with 49. Now we know 49 is a pretty easy number. It's going to start with a 0, so we always start with a 0. Even for 55, we start with a 0. And 49 is easy because, well, we don't have 64, but we have 32 in there. And 49 minus 32 is 17. And to build 17, we just need a 16 and a 1. Right? So that's pretty easy. And the rest of these are going to be zeros. 55 is pretty easy as well. We know 64 is bigger than 55, so there's nothing there. We know that there's a 32, and 55 minus 32 is going to be 23. 23 minus 16 is going to give us 7, and to build 7, that's going to be 4 plus 2 plus 1, and we have a 0 there, right? So these are the numbers that we are going to add together. So down here, we're going to do the addition. So it's going to be 49 plus 55. And 49 in its binary form 00110001, 55 0011 0111. All right, now, and by the way, when we add these together, that's 104. All right, so whatever we get for our answer had better be 104. All right, so let's check this out. Now we know 1 plus 1 is 2, but wait, we can't get a 2 in binary. All right, so instead, remember, 2 is 10, 1 plus 1 is going to be 10. So the first 0, and if I may, 1 plus 1 is 10 in binary. So the 0 is going to go in the first slot, and then we're going to carry. Right? Now we have 1 plus 0 plus 1, and that's 10 again. 1 plus 0 plus 1 is 10 again. All right? And then finally, 1 plus 0 is 1. All right, so now we ran out of carries. 1 plus 1 is 2, but remember, we can't get a 2. We get a 10. Right, so once again, we're carrying. 1 plus 1 plus 1 is 3, but we can't get a 3. We get 11. Right, so remember, 3 is 11. So that's going to be a 1 here and then a 1 up here. And 1 plus 0 plus 1. So 1 plus 0 plus 1 is 1. And then right here is 0. All right, so this is our sign bit. And the sign is positive, so that means we don't have to take the 2's complement. So our answer right now is 0110100 in base 2. But does that equal 104? That's the question. All right, so let's see if it does. So we know that this is 64, this is 32, and then we have 8. So if we add 64 plus 32 plus 8, that should give us 104. We know 32 and 8 is 40. 40 and 64 is 108. Or 104, excuse me. All right. So it seems like the process works, and undoubtedly it does. Right? But what happens when we start putting negative numbers in there? Right? So let's take a look at a second example. So for letter B, we have 53 plus a negative 102. And this is where we're going to have to start using that 2's complement. Okay. So if we do this, we're going to start with our sign bit. And for both, we start out with 0 as the sign. And I know 102 is negative, but we're going to take care of the sign in a moment. No big deal. And then we have 64. And we could just go right down the list. So 64 and 32 and 16 and 8 and 4 and 2 and 1. And that's our 8 bits. All right, so let's start with 53. 53 is pretty easy. If we subtract 32 from 53, that leaves us with 21. And now we have 5. All right, so 21 minus 16 is 5. And to get 5, we just need a 4 and a 1. All right, so that one's pretty easy. And then we need 102. Right? So 102, we definitely need a 64. And if we subtract 64 from 102, right, that's going to leave us with 38. Right? And we just need 32. And that just means we need 6 more. So 6 is 4 and 2. All right. However, 102 is negative. All right. So we are going to have to take the 2's complement. Right? And let's just write down here. It's going to be the 2's complement of 0, 1, 1, 0, 0, 1, 1, 0. So what we're going to do is we're going to flip the bits. Okay, so all we're going to do is we're going to change all the bits around. All right, so we do that, and then we're just going to add 1 more. Now remember, 1 plus 1 in binary is 10. And then everything else is the same. All right, so this is the 2's complement right here. Now what we're going to do is we're going to add this 53 in binary to this 2's complement. Okay, so 53, and now we have negative 102. right? So remember 53 was 0, 0, 1, 1, 0, 1, 0, 1, and 1, 0, 0, 1, 1, 0, 1, 0. And we're just going to add these. Right? So the good news is for this one, it's pretty easy to add. So 1 and a 0, 1 and 0, 1 and 0, 1 and 0. And now we start having a carry. All right, so remember 1 plus 1 in binary is 10. Right, so we have to carry the 1. 1 plus 1 is 10. Carry 1 plus 0 is 1 and 1. All right, so now what is this? Well, this is not quite the answer. Okay, and the reason is because we see the sign bit. And we notice that the sign bit is 1. So whenever the sign bit is 1, what that means is we have to take the 2's complement again. All right, so we're just going to do it one more time. So over here, we're going to flip all of the 1s and 0s. So this is just our 2's complement. So 0, 0, 1, 1, and then 0, 0, 0, 0. And then we add 1. All right, so this one's actually really easy. So it's 0, 0, 1, 1, 0, 0, 0, 1. And remember, it's a negative at this point. So it's going to be negative, right, base 2. And let's just make sure that this makes sense. Right, so up here, if we subtract these, that's 49. Okay, I don't think anybody doubts that 53 or 102 minus 53 is going to give us a negative 49. So let's see if we can get a 49 out of this. All right, let's hope so. All right, so in decimal, this is a 1, 2, 4, 8, 16, and 32. All right, so 32 and 16 is 48, 48 and 1 is 49. So this is negative 49 in base 10, which makes sense. All right, so that's the process that the computer uses to be able to add both positive and negative numbers within a given domain. All right, so now clearly, if this number instead of 53 was negative 53, well, then our answer would be a lot higher, or excuse me, a lot lower than negative 128, all right, which is probably the minimum value that we can hold. Or if this were a positive, the number would be bigger than positive 127, which is the maximum of this method. So then what would happen is you'd have to use another bit to be able to do this. All right? So a suggestion might be for you to work on this last one by yourself, see if you can do it. And then in the final video in this section, I'll go through the solution to this.